Okay, we're going to go over using sine law. And sine law is a law you can use to solve for any acute triangle. An acute triangle is where all of the angles inside have acute angles, or even a right angle triangle. You can use sine law to solve. Okay, we have two examples here, and I guess we should write the law out first so that you see it. Law, this formula is written as sine A over A is equal to sine B over B is equal to sine C over C. And what these are, okay, these stand for angles within a triangle, the uppercase letters, and these stand for the corresponding sides. So the lowercase is the side of a triangle, and the uppercase is the angle of a triangle. If we were to name that triangle, it would kind of look like this. Reference, we'd call this angle A. Therefore, opposite of that angle is side A. If this was angle B, opposite would be side B. And if this was angle C, the opposite of it would be side C. So that's how we name triangles. And you can rename a triangle to anything you want. I could call this A, and if that doesn't really suit me, I can go, no, you know what, scratch that. I'm going to call this A, and this B, and this C. Okay, in acute triangles. Usually with right angle triangles, they refer to C as the hypotenuse, just for Pythagorean's theorem. Okay, but in this case, A, B, or C, it doesn't really matter. Now, what this is a ratio. They call it sine law, but it should really be called sine ratio. We have three ratios here. And it's what it's saying is the ratio of these two sides is equal to the ratio of these two sides is equal to the ratio of these two sides. And when doing ratios, these are the idea of equivalent fractions. I only actually need to use two at a time. Or maybe use A and B together. Or I use side B and side C together. Or I use A and C together. Idea being is we can always cross out the other one. We only need to set two equal to each other. So what does that mean for this? Well, in order to use sine law, you have to have a complete ratio. And what that means is you need an opposite angle and an opposite side in order to use sine law. If you don't, then you can't use sine law. For instance, let's say I quickly build a small triangle here. I'll build it on the side. Oops. Okay, and maybe this triangle is 3, 4, 5. Okay, and find this angle x. Well, in this case, I would have all the measurements of the sides, so I could replace, 3, 4, 5. But would I have any of the corresponding angles? No. So I don't have a complete set of ratios. Therefore, I can't use sine law. And we'll go about that after, that you actually have to use cosine law to solve this, okay? So I can't use sine law. So I need to have a complete ratio. So when I look in this, I'm just going to name this triangle. We'll call this A, which makes this A. We'll call this B, which makes this B. And we'll call this C, which makes this C. Do I have any complete ratios? The measurements for any complete ratio.
Yeah.
Yeah? Which one?
A.
A, that's right. I have the angle of A, and I have the side of A. Great. Which means I could probably use, as long as I have one other piece of information. You technically need 3 pieces of information to solve for anything with a triangle. So I have 3, that's my first requirement, and I have a complete ratio, so I can use sine law. There's our check. So let's plug our information into this little formula here. Okay. And recall that I called this angle A. Okay, so we're going to replace 72 with the A there, and 16 will replace the lowercase a. Our B, well, there's our angle B, which is 56. And our side B is our unknown, so we'll put there's our B. And C, we have no information for either of these. So we're just going to call them C and C. So let's plug this stuff in. Okay, so this becomes sine 72, that was our angle, divided by 16. Which is then equal to sine 56 divided by our x, right? That was our unknown, and which is equal to sine c over sine c. Now remember I said we only need to set up a pairing of ratios. Well, this really isn't giving us any information, So you don't need that. You kind of drop that from the equation. So I'll move down and start writing the rest in black here, because now we're going to be just equating. Now the sine 72 over 16 is equal to sine 56 over x. Okay. Now I'm going to show you a trick. They usually show you sine law as two different formulas. What they do is they show you this law here, and then they invert it, where this goes on top and the sine A is on the bottom, and all of these are inverted. They're actually the exact same thing. Okay, and what it is whenever the unknown is on top, it's usually easier to solve for a fraction where our unknown's on top. And if you notice, our unknown's on the bottom right now. Okay, so what I can do is I can really flip this whole fraction. And proof of this is in this idea here. 1 over 2 is equal to 2 over 4. Would you say that's true? Okay, let's invert these and see if it's still true. This becomes 2 over 1 is equal to 4 over 2. Is that still true? Yeah, it's still true. So in other words, I can flip fractions, equivalent fractions, and everything will stay true. So that'll help me. Instead of isolating x here, I'm just going to flip everything, okay? And this will kind of help us to solve stuff. It'll make it easier so we only remember one formula. So this becomes 16 over sine 72 is equal to x over sine 56. Does this step make sense so far? Yeah. Well, the goal is to just isolate for x. So in order to isolate for x, what do I need to move to the other side?
Sine 56.
Yeah, and because this is division, when it goes to the other side, what will it become?
Multiplication.
Multiplication. So this is going to read x is equal to sine 56 times 16, all divided by sine 72. This is just simply putting numbers into a calculator. Okay, my calculator is not the easiest to put numbers into, but for instance, you might hit sine first on yours, and it doesn't quite go on mine. So I actually have to type my angle in first, and I have to make sure my calculator is in degrees. That's important. So 56 sine, that's what this is equal to, 0.829, large decimal, times 16 equals, okay? So the top of this would be equal to this, and I'm going to divide it by my sine 72. Divided by bracket 72 sine, okay, so that's the bottom, is equal to. So it turns out that x is equal to 13.94, which is fine, 13.94, and I think we're in centimeters. Okay, so we just solved for this side. And we're going to use some logic here, 13.94 centimeters. Let's use some logic here. Which of these angles was larger, A or B?
A.
A. Which of these sides was larger, A or B?
A.
A. Think of it like a mouth opening. The wider we open the mouth, the farther the distance is from the top of our mouth to the bottom of our mouth. So the larger angles should have the larger opposite sides, right? Because this is a smaller opening, the difference is not as much. Does that make sense? Okay, so that's how to solve a side. I don't know how we're doing for time. We'll go into now solving for an angle. Now this is a little different. Okay, it's still the same idea. Do I have a complete ratio here?
No.
Are any of these ratios complete?
Oh, yeah.
Yeah. Have we named it yet?
No.
No. So let's name it. What do you want to name that?
C.
Yeah, good idea. Let's call it C. Something different this time. And then what do you want to name the other one?
A.
A. Okay. Here, A. Does it matter what we name the one we have no information about?
No.
No. It's obviously B, right?
Yeah.
But that's not going to help us much. So instead of putting the whole formula out, let's just try to put our ratio together. We'll probably need to zoom out just a little in order to do this. Okay, so we'll put a line here. We're working on our next sign here. So according to our formula, we have B and C. So let's go sine. What is our angle for B? Oh, sorry, not B and C. A and C. What is our angle for A?
X.
X. Sine X. Over, what is our angle, or what is our side length for A?
18.
18. Okay, what is our angle for C?
19? No. Is that 62?
Yeah, that's
Oh,
62. What is our side length for C?
19.
Good. So we set it up. We didn't actually set up our B, we just put our A and our C together, and I didn't even write this part out. Was that okay to do? Were you okay with that?
Yeah.
Okay. Our unknown's on top, so I don't have to do any inverting. This works out really well. We want to get X by itself, so I move 18 over, and when I move 18 over, what does it become? Because it's division here.
Times 18.
Yeah, times 18. So let's rewrite this. It now says sine x is equal to sine 62 times 18. Okay, all divided by 19. Okay, so we can equate all of this. Did you want to try it on your calculator there?
Sure.
Yeah, give it a try and I'll follow along. So that sine x is equal to 62 sine. What did you get?
For the top?
Altogether.
Oh, okay. 0.78.
You got a 78. Is your calculator in degrees? Double check it, because you should get this. I'll double check my numbers. 62 sine.
It's in grad.
No, you have to change it to degrees.
Okay.
18 divided by 19.
Okay.
I'll show you in a sec. So let's follow here.
Yeah.
So this is the number you should have got. I double checked it. 0.836. Okay, so is equal to roughly 0.836. Now here's the tough part. The goal is actually to only isolate x. So this sign has to move to the other side. But you'll notice on a calculator you can't divide by sign. In order to move sign to the other side, we have to do the inverse. And inverses is something you'll learn maybe in grade 11, the idea. But for now, just think of it like this. When I move sine to the other side, it becomes this. And you'll be able to find this on your calculator. Sine to the inverse. So the power of -1 is 0.836. Okay. So on my calculator, when I go to put that in, if you'll notice, I already have this number in the calculator. I have to hit shift. Usually it's shift on yours. This is my shift button. So you'll notice my sign is going to shift to sine -1. And then I hit that. Okay. It ends up being 56.76. So what that's saying is that's how many degrees my answer was for my sine law.